Okay, this is chapter 5, section 1, angles of triangles. So let's first start by talking about what a triangle is. A triangle is a figure formed by three segments joining three non-collinear points, okay? So those 3 points, two of them are gonna lie on the same line, but one of them has to lie off of that line. If you had 3 points that were collinear, then you would just have a straight line. One of them has to be off the line in order to form a triangle. The point where the segments meet, that's called a vertex, and multiple of them would be vertices, okay? Let's highlight that bullet point and let's label the 3 vertices on our image. So we've got vertex A, vertex C, and vertex B, okay? Each triangle is going to have 3 vertices. Now, the segments will be the sides. So each of these sides from C to A, that's one segment. Another segment would be from A to B, and the last segment would be from C to B, okay? So there's 3 vertices, 3 sides, and 3 angles. Angle A, angle B, and angle C. The angles are the inside of the triangle, the angles formed by the inside. So there's 3 of them. Okay, now there's different classifications of these triangles based on their sides. You can also classify them by their angles. Classifying them by their sides though, if none of the sides are the same length, we call it scalene. If at least 2 of the sides are the same length, we call it isosceles. And if all sides are the same length, we call it equilateral, okay? So for scalene, there's no congruent sides, so they're all different lengths. For isosceles, 2 of the sides are the same. And then for equilateral, all 3 are the same length. Now, we can also classify them based on their angles. So an acute triangle is where all angles are less than 90 degrees. Okay? Obtuse would mean that one angle is greater than 90 degrees. A right triangle would be at one angle is exactly equal to 90 degrees, okay? In other words, it's got a right angle mark. And then equiangular means all angles are the same, okay? So acute means that there's 3 acute angles. Right means that there's 1 right angle. And obtuse means that there's 1 obtuse angle, okay? Oops. Now, let's take a look at this triangle, okay? And let's use these protractors to figure out the measure in the degrees. We're gonna use that for something in a little bit, okay? So the first angle, angle A, I would say is roughly 18 degrees, okay? Going from the bottom all the way up, it roughly hits about the 18 degree mark, okay? So let's label that one as 18 degrees. The next one, angle C, okay? We're starting at 0, we go all the way to about, I would say that's about 52 degrees, okay? Roughly. And then the last one, we're counting backwards. So we're gonna backtrack from 180, so we go from 180. Let's just say that this crosses exactly at 70. So we're gonna do 180 minus the 70 degrees over on the right side. That will give us, in this area, 110 degrees. So we've got 3 angles, 110, 52, and 18. I want you to add them together, okay? So 110 plus 52 plus 18. Well, 52 plus 18 is gonna give me 70. 110 plus 70 is gonna give me 180, okay? Now, that is true for any triangle. I want you to write that down. True for any triangle, okay? When you add those 3 angles together, you will always get 180 degrees, no matter what you do, okay? Now, it's called the triangle sum theorem, and it says the sum of the measures of the interior angles of a triangle is 180 degrees. In other words, if you were to add the measure of angle A plus the measure of angle B plus the measure of angle C, you would get 180 degrees. Now let's take a look here. The acute angles of a right triangle are complementary. Explain why. The acute angles of a right triangle are complementary. Well, let's start by drawing a right triangle. So we know a right triangle has to have a 90-degree mark. So this angle is 90 degrees. Why would the two acute angles need to be complementary? Well, if inside of a triangle we have 180 degrees to deal with, right? We're saying that that's equal to 90 degrees plus, let's say, angle 1 and angle 2, plus the measure of angle 1 plus the measure of angle 2, right? Now, if one angle's already 90, we subtract that 90 from both sides. We'll end up getting 90 equals the measure of angle 1 plus the measure of angle 2. Remember, when two angles add together to give us 90 degrees, they're complementary. So this is why they're complementary. Nice. Sorry, guys. Okay. And I'm jumping all over. Exterior angle theorem. So not only will we talk about the interior angles to the triangle, the angles on the inside, we're also going to talk about the angles on the outside of the triangle, okay? So the measure of an exterior angle of a triangle equals the sum of the measures of the two remote or non-adjacent interior angles. So in other words, let's take a look at this example. Angle 1, which is this angle right here, is going to be equal to the two angles that are interior but not next to angle 1, okay? The angle that's interior that's next to angle 1 is C. So we're not going to look at C. We're going to look at B and A, okay? So angle 1 is equal to the measure of angle A plus the measure of angle B, okay? So, and any exterior angle is equal to the two remote, non-adjacent interior angles. All right, here's another look at what interior versus exterior angles look like. Notice, the exterior angles are all inside your triangle. The exterior angles are all outside your triangle. So the corollary to the triangle sum theorem is that two acute angles of a right triangle are complementary. We just proved that on a few slides ago, okay? So the measure of angle A plus the measure of angle B, given that angle C is 90, those must add up to 90 degrees. Okay, so let's try some examples. Example 1, it says state whether the triangle with two angles having the given measures is acute, right, or obtuse. Well, if we have a triangle and two of the measures are 55 and 43, how we find the third angle is we take 180 and we subtract 55 from it. We also subtract 43 from it, and that'll give us the measure of our last angle. That will tell us whether it is acute, obtuse, or a right triangle. 55 and 43 added together give me 98. Take that away from 180 and you get 82 degrees. All of those three angles, 55, 43, and 82, are all acute, so this is an acute triangle. Let's do the next one. We've got 47, 43. Let me use a different color. Sorry. 47, 43. And now let's do 180 minus 47 minus 43. And 47 and 43 combined to give me 90. 180 minus 90 is 90 degrees. So my last angle is 90. Whenever you have an angle that is 90 degrees, your triangle is a right triangle. Okay? Next one, we've got 80, we've got 75. So we do 180 minus 80 minus 75 gives me 25 degrees, which is an acute triangle. Okay? Remember, whenever your angles, all three of them, are less than 90 degrees, you've got an acute triangle. All right, let's keep going. We've got 30, 30. So 180 minus 33 minus 33 equals, well, 33 and 33 give me 66. 180 minus 66 gives me 112 degrees. That is larger than 90 degrees. This is obtuse. And the last one, we've got 24, 66, 180, minus 24, minus 66. 24 and 66 gives me 90, so I get 180 minus 90, which is 90 degrees, and that is a right triangle. Okay? Pretty simple when you break it down like this. Okay, for the next part, we're going to find the measure of angle A for each of these diagrams, okay? In the first figure, okay, we've got two triangles where one of their angles is vertical to the other angle on the other triangle, okay? So we know that those two angles are the same. Now, we can use the information in the triangle on the left, this one, to help us figure out that missing angle. Now, how we figure out that missing angle is we know the entire angle, we know the entire triangle has a measure of 180, and then we're going to subtract 80 from it and subtract 50 from it. That means that our last angle has to be 100 minus 50, which is just 50 degrees. So this last angle is 50 degrees. That means the angle on the other side is also 50 degrees. So if two angles inside this triangle are 50, we do 180 minus 50 minus 50, and that will give us 80 degrees. 180 minus 100 is 80. That angle A must be 80 degrees. Okay, B. This congruence mark means that this angle and this angle are the same. Now, let's use the bottom triangle to help us figure out what A is, okay? 60 and 40 gives me 100, so this last angle needs to be 80 degrees. Because remember, it needs to be 180 minus 40 minus 60, so my leftover is 80 degrees. Since it's 80, this angle up here also needs to be 80, so angle A needs to be 60 degrees in order for all of this to add up to 180, okay? And our last example. We've got 30, we've got 110, and then we've got an angle that we don't know, okay? I'm looking over here on the right. This angle is going to be the same as this one over here, so that'll help us figure out what angle A needs to be. We've got 30, we've got 110, so we take both of those away from 180, minus 110, minus 30. We're going to get 180 minus 140, which is 180, or no, I'm sorry, it's just 40. So our last angle is 40 degrees. Now we can go ahead and fill in this angle as 40 because we know it's going to be the same. And now we have to figure out our last angle. So we do 180 minus 40 minus 30. We're going to get 180 minus 70, which is 110 degrees. So we know, find the measure of angle A. All right, now this is a different example, okay? This is dealing with exterior angles. So we've got 120. Remember, your exterior angle, which is 120, is going to be equal to the two non-adjacent interior angles. One of them would be 80, the other one would be angle A. So we're going to say 120 equals 80 plus the measure of angle A. In this case, we would subtract 80 from both sides, and we would get 40 equals the measure of angle A. So this would be 40 degrees. Now, there is another way to do this problem, okay? The other way is to identify, okay, this is a line, so this 120 and this angle over here are a linear pair. So this angle must be 60, and you could have taken 60 and 80, added them together, and you would have gotten 140. Take that away from 180, and you know the last angle inside your triangle needs to be 40 degrees, okay? That method does not work all the time. It works it does work all the time, but it gets more complicated when we add variables. So in some of the later examples in this lesson, make sure that you're not using that method because it'll make things a little bit more complicated. You're going to add steps that you don't necessarily need to, okay? So in EFG, that's this triangle that I'll highlight for you guys, EFG, okay? The measure of angle G, that's this one, is 100 degrees. And the measure of FEH, yes, E is supposed to be right here, okay, is 3 times the measure of angle F, okay? So this is angle F. It says find the measure of angle F. Well, let's use the fact that we know this exterior angle, 3 times the measure of angle F, needs to be the 2 interior angles that are not next to it added together. So let's set up an equation like that. 3 times the measure of angle F equals the measure of angle F plus 100 degrees. If I could write. Okay. Now, we're going to treat the measure of angle F just like a variable x. So we're going to say x equals the measure of angle F, okay? If you understand that the measure of angle F can just be used as a variable, this step is not for you, okay? This is if you're having trouble recognizing that the measure of angle F can just be treated like another variable, okay? So we're going to substitute x wherever we see the measure of angle F. So this is going to be 3x equals x plus 100, okay? All I did was I substituted in x wherever I saw the measure of angle F, okay? So now all I have to do is subtract x from both sides. We would get 2x equals 100 degrees. Divide by 2, and I would get x equals 50 degrees. Now, if x is 50 degrees, that means that the measure of angle F is equal to 50 degrees. Okay, example 3. This is where I don't want you guys using the fact that this is 180 minus this angle, okay? That's not what I want you guys to do, okay? I want you guys to use the formula that this exterior angle is going to be equal to the 2 non-adjacent interiors added together. So 2x minus 5 is going to be equal to x plus 70 degrees. So from here, you can either add 5 or subtract x first. I'm going to add 5 first. Once I add 5 to both sides, I'm going to get 2x equals x plus 75. Once I do that, I'm going to subtract x from both sides, and I'm going to get that x equals 75. Now, our question here was not asking for the value of x. It wants to know the measure of the angle JKM. Well, the measure of angle JKM, based on the diagram, is equal to 2x minus 5. So we're just going to take our x, plug it in there, and we're going to get that this is equal to 2 times 75 minus 5, which is going to be 150 minus 5, which is 145. So our missing angle JKM we just found was 145 degrees. All right, last example, peeps. It says find the measure of each acute angle. Okay, find the measure of each acute angle. Well, the one angle that is not acute is this right angle, this 90 degrees. So we're obviously trying to find this angle and this angle. Remember, if it's a right triangle, you know that the 2 acute angles need to be complementary. So we need to do 2x plus x minus 6 is going to be equal to 90 degrees. From here, we've got 2x plus x minus 6 equals 90. You can just get rid of those parentheses. And we're going to add 2x and x. We're going to get 3x minus 6 equals 90. Then you can add 6 to both sides. You would get 3x equals 96. Divide by 3, and you would get x equals 32. Now, we just found x. We did not find the measure of each acute angle. we're gonna take that 32 and plug it into both acute angles. So we've got 2 times 32, which is 64. So one of our angles is 64 degrees. We've also got 32 minus 6, which gives us 26 degrees. And these should both add up to 90, which they do. Okay, so we are perfect. Okay, and my last slide, I want you really quickly to tell me what part of the lesson that made the most sense to you and the part of the lesson that was most confusing to you, okay? If I was filling this out the first time I went over this lesson, the part that made the most sense to me was that all angles in a triangle add to 180 degrees. And the part that was the most confusing was the part about the exterior angles. Okay? But how we always get better at these is we do the practice, okay? So just keep practicing with those exterior angles and you will get much better, okay?